Hi there, in this video I'm going to build an Olivetti M20 computer on a single PC board. This is not my design, this is Salvatore Paxia's design, but he was kind enough to send me one of these so that I could build it. And you're going to get to see me do a little bit of work on it here. I don't usually film myself soldering stuff, but you'll see the sockets show up on the board, you'll see the chips show up on the board, etc. And then we'll go through the parts on the board. And you'll see it boot and run M20's PC OS. So why did I decide to do this? Well, I've been doing some projects lately with the Zilog Z8000 microprocessor. You might have seen it, my Z8000 modular computer, also known as the Clover computer. If you've seen that, then you've learned a bit about the Z8000 and how it's a 16-bit processor from Zilog that largely was not commercially successful. It's kind of an oddity. You can still find it on eBay. But there was one company, actually a few companies, but Olivetti was one of the primary ones, that managed to make this Olivetti M20 computer using the Z8000. So the Olivetti M20 was manufactured in Italy, and it was a small, sort of a business class computer, I think. It would typically come with a couple of floppy drives, like the original IBM PC. There was a variant of it with a hard drive, you know, like the IBM XT. And it had a little bit of an advantage that it was 16-bit. But I think basically, you know, they lost the battle against the other mainstream 16-bit computers, you know, the x86 line. And this computer was largely, you know, forgotten to history, but there's still a few people out there who have some or trying to acquire some just for the uniqueness of it. Salvatore Paxia, a fellow forum user, he sent me this motherboard in the mail, and this is a modern reproduction of an Olivetti M20. And to find an actual Olivetti M20, it's very hard. I've been looking on eBay for quite a while, but nothing has popped up. But Salvatore, he's got this project here to recreate one. Now, it does have a few modern conveniences on it. You'll notice here some PLCC sockets. It's using a few large PLD devices. It's using some dual ported RAM. So we're going to go ahead and we're going to build this thing and try it out. Now this is a pre-production version of the board, so there are a few problems. This is exactly as I received it. It had a few sockets already mounted, but there are a few bodges that have been done already on the back, and Salvatore told me about those. There's also an additional one I have to do on one of the dynamic, or one of the static RAMs. So a few things there that'll be corrected in the next board revision, as well as there's a problem with the ATX power connector, and Salvatore sent me this adapter here that will fix the pinout. So I think what happened is, you know, there's two different ways of numbering pins on connectors. You can go 1, 2, 3, 4, 5, 6, 7, 8, or you could go 1, 2, 3, 4, 5, 6, 7, 8. I think whatever pinout he used when he created that was the wrong one. So it looks like this corrects the numbering from the sort of the zigzag numbering to the straight up down numbering, or vice versa. But anyway, okay, it was a bit of work, but I think everything is now soldered up and ready to try out. I may try powering it up first, which I will probably hook up power supply here. I do have a power supply. So what I usually use is one of these guys, which is a mini box Pico PSU. You give it 12 volts and it gives you the 5 and the 3.3, and it does the power switch. It's got connectors here for your drives. Now, if this connector was wired right, you'd be able to plug this simply into wherever it goes right there. Unfortunately, the connector's not wired right, so we'll have to use this jumper cable, like so. Then we can plug the Pico PSU into here. Okay, I'm going to go ahead and turn on the 12 volt. Nothing is lit up yet, but I think if we short this jumper over here, it should turn on the ATX power supply. Well, it did not. Okay, we're going to try this again. What I have done is I have installed this chip here, which is a small PIC microcontroller, and I looked on the schematic and the power switch routes up to this PIC and then back to the power supply. So this PIC is actually used to do the PS2 keyboard emulation. Now if we toggle this, there we go. green light, we've got power. And then if we look at a typical IC, there's something, I don't know, this one here maybe. I'll just take a guess at where the power rails ought to be. Yep, 5 volts, as it should be. So I'm ready to stuff this thing with ICs at this point, I think. Okay, let's take a closer look at the PC board. Usually when I do one of my projects, in the video I will go through a lengthy review of the schematics, but this is not my design, so I'm not going to go into the schematics in detail. But what I'm going to do is I'm going to point out the major functional components on this board so people can get an idea of what it is. So let's start here. We've got the Zilog Z8000 microprocessor. If you've watched my other videos on the Z8000 modular computer that I designed and built, you'd already understand what a Z8000 is, but the Olivetti has one as well. It's sitting right there. We have a couple of RAM chips for it. AS6C 4008 is a 16-bit microprocessor, so we have to have 2 RAM chips. We have VGA output. Now the VGA is done with some dual port RAM. These are IDT 700, I think they're 7005s. Dual port RAMs. You can put in bigger RAMs to get color mode. But we've got 2 dual ported RAMs going to a large CPLD device. And this CPLD is programmed to take what's in these RAMs and turn it into VGA and send it out the VGA port over here. So one of the things that a viewer actually asked me on my last project on the Z8000 was, why don't more people do native VGA displays on vintage computers? You know, this going through a RGB output into a scan converter, all that's a lot of work. Better to do VGA, and this one here actually implements that. It's got a native VGA solution. Now this is of course not what Olivetti did back in the day. It's a modern take on that, but you know, this is pretty cool. You've got the dual ported RAM, so you don't have to worry about synchronizing access to the RAM between the video controller and the CPU, and you've got the whole VGA implemented in this chip, and you've got excellent high quality VGA output over there. So that gave you the RAM and the video. There are no ROMs on this board, at least not directly. What it has is it has an Atmega, this large Atmega here, and this is responsible for copying the bootloader into RAM and then resetting the CPU. So that's the same technique I think that 4Sun5BU on his Z8000 computer used. You do end up with a modern microcontroller in here, this Atmega, so for vintage purists, you may have an issue with Atmegas showing up on the board, but it is a really convenient way to bootstrap this microprocessor. To do this with a ROM, you would need to put actually 2 ROMs in, because again it's 16-bit, and you would need to have the reset circuit to switch the ROM in at the right part, get the boot vector off of it, then rearrange the memory so RAM is down there. I did all of that in my first Z8000 video, but this here is another way to go about it, just using Atmega. Over here we have another one of these large CPLD devices that implements a whole lot of glue logic. So I have not looked at what's in this one, but I'm thinking you probably have all of the I/O address decoding, the memory segment decoding, all of that is probably in there, and you know, probably like a dozen or 2 dozen glue chips probably ended up in there and eliminated a lot of extra chips on the board. Over here we have a pair of 8251s. I think those are serial chips. It has 1 serial port here. I don't know why it's got 2 chips. There is another header over here which might go to one of the chips. I'll have to ask the designer exactly where these ports are going, whether there's 2 ports or I have not tried to get any serial out of them yet. Over here you have an 8253 counter timer chip, and you have an 8259 interrupt controller, and then an 8255 parallel I/O hooked up to this connector here, this DB25 parallel I/O connector. Now it does have some sound output. There are 2 SN76489 sound chips, so that is the same sound generator I believe that's used in the PC Junior and the Tandy 1000. That is not an original Olivetti thing. All Olivetti came up with was the beeper, the little piezo buzzer over here. So these were added on by the designer so that we could have some nice sound on this. I did actually try out the sound in the monitor doing some raw port IOs, and I managed to get a tone out of it. So it works, but I need to write a program that'll actually play some music or do something interesting with those. But they come out and they go out to this little 1/8 audio jack here. For keyboard, we've got a PS2 keyboard connector here and another little pick controller right here that handles the translation between the PS2 keyboard and the Olivetti keyboard. A couple jumpers here select whether you go with the PS2 keyboard or there's a header somewhere on the board for the Olivetti keyboard. So the Olivetti itself would have had a custom keyboard that went with it. But most people who build one of these are going to build it using the PS2. Over here we've got the floppy controller, a WD2797 floppy controller with its associated glue logic and such, and some pots that you need to set up to set the timing on it, and a trimmer over here. There's a procedure outline for setting that up, the header for the floppy. Over here you've got your IDE header right here, along with some data buffers and such that go along with that. And then you've got configuration switches here. Right here is your header for your ATX power supply. Now there are a couple slots over here for Olivetti expansion cards. I did not populate those because I have no expansion cards. If there is a respin of the board that corrects some of the problems like the incorrect pinout on the ATX connector, I was kind of saving my expansion card connectors to go with that one. So when the designer does come out with a new one, I'll probably build it up as well, and we'll see what other changes happen in that. You have a couple headers here unpopulated. These are for in-circuit programming, I assume, of the Atmega and at least one of the CPLDs. I don't know if this hooks up to both of them. I wasn't quite sure, but at least one of these is probably hooked up to that header there. You've got a button here that handles reset. Jumper over here for the power switch. All in all, it's a very clean circuit board, and it is actually ATX form factor, so all of these holes should be in the right place to mount this in an ATX case. Now the slots may not match up to the slot openings in the back, and of course where these connectors here come out may not match up to what is in the ATX, your little I/O backplane in your ATX case. But all in all, this should mount down to at least the bottom of the case. Okay, I think we're ready to give this thing a shot. I have socketed all of the ICs except a few. These two here were intentionally left out. I think they're the upper 8 bits of the IDE bus, and this one here is the Max 232 for the serial. Haven't put those in yet because we can use TTL serial as an option, and I think we don't use those upper 8 bits of the IDE. So everything else should be in here, should be ready to go. I've got it powered up. I'll just short the thing here to turn on the power, and we'll hope there's no smoke. There we go. We're getting VGA signals going through diagnostics. I don't know what EC4 is. That could be an error of some sort. I'll have to look into the diagnostics on that. Let's see if we can reset it and see if it gives us an EC64 again. Obviously we don't have a floppy hooked up now, so it's not going to be happy about not having its floppy drive. There we go, no EC4 error this time. So I've reset it several times. I don't know, I'm going to have to look up that error code, see if it's something problematic or not. Okay, let's see if we can get the thing to actually boot up this time. So what I have here is I have my GoTech. It's in a plastic bracket that I 3D printed, but it's just a standard GoTech with an OLED display, UPS drive here that I put some images on. It's running the flash floppy firmware. So that is all set up. I hooked it up to standard PC floppy cable. I'm taking the gamble and saying not to use the split and the twist because that's kind of a PC thing. So I've wired it to the first connector on the cable, hooked it to the floppy port. I've hooked the power up from the GoTech to the Pico PSU, so we'll have power to power up the GoTech. And then we'll turn this on. I'm going to switch view over to the monitor so we can see the boot sequence and see if it'll boot up. Got power. Got VGA. There's the bootstrap loader coming up. Disk error, drive 10, that is the compact flash, I think, that is not installed. Blank screen, hopefully it's booting off the floppy. Looks like the flash floppy's kind of blinking. Okay, there we go. Basic system configuration. Black and white, lots of memory. There we go, PCOS 4.1a. That is the professional computer operating system. Not personal computer operating system, but professional computer operating system. And I've already looked up a few commands, like I can do VL, should list the files on the volume. It's accessing the floppy. This whole thing is kind of slow. Yeah, very slow. Any key to continue. Yeah, the documentation said VL can be kind of slow. So there's actually lots of, for a floppy, this is quite a few files. I wonder how many bytes it is. Maybe it'll give me a byte subtotal at the end. Subtotals. It didn't give me a total amount of bytes. But anyway, there's also a command VQ that should be faster than VL. Yeah, quite a bit for a floppy. Let's try basic. It is loading. All right. Can I control C it? System. Let's see if we can install the hard drive. Okay, it's time to put some storage on this. So I have some options. I've got a compact flash adapter, very popular. Find these on Amazon, eBay, wherever. And then I've also got this hyperdisk. This actually was listed as a Transcend. It says hyperdisk on it. Maybe one of them is the OEM for the other. I don't know. But this is an industrial flash module, a little bit better than a compact flash, and you can buy these kind of cheap on eBay too. It's like a 32 megabyte one here. But one thing I noticed when I went to do this is that this is a 40-pin IDE here. This is a 44-pin connector. Now, you can just omit the last 4 pins and you'll get 40-pin connector. So if I'd have just left those off, I'd be fine. I could actually just take the flush cutters, just cut them off. That'd probably be fine. But with them sitting in there to try to plug this in, the extra pins, they kind of hit this connector and it won't go on. So I did make myself, I had to break from the video and I made myself an adapter. And it does actually fit in there. You can plug it, whoops, let's line it up right. You can plug it in like so, it'll plug in all the way. And you'll be able to do your, plug in your 40-pin device up there and you won't be hitting those extra pins. So for this demo, what I'm going to do is I'm going to try out this disc on module. Let me just plug it into this. Make sure we get pin 1 where it's supposed to go. Pin 1 is marked on there. Plug it into here. Make sure we're not offset a pin or anything. There we go. Now we're ready to boot it up and see what happens. Okay, invalid file area 00 on drive 10. Well, we've not initialized the disk yet, so that's not surprising. Booting the floppy. Okay. And then VF should format a disk. And 10, I think, is the hard drive. Deletes all files, yeah. Okay, that's going really fast, but it is a flash drive. All right, and it says 10 there. So does that mean we're on drive 10? VQ is still printing volume 0. Can I VQ volume 10? Okay. Free disk blocks, 34,000. That seems like a lot. Let's see if we can copy the boot floppy onto the hard drive. I think the operating system is in this PCOS.save. I think I read that in the manual. So let's try FC for fcopy. I'm going to do volume 0, star to volume 10. And let's see if it'll do that. Okay, it's going to copy each file, so we'll let it sit here and copy for a while. Okay, it looks like it has copied all of the files. Now if we do a VQ on drive 10, they're all there. Let's try a VL on 10 and see if it's faster now. Oh yeah, that's much faster. Of course, it's coming off of a flash drive, but yeah, that's a little more usable. Okay, so I'm wondering now, is the thing going to boot off of the IDE storage device since I've copied the files, or is it like DOS where you've got to do something special to copy the OS? I'm hoping it just boots since we copied that PCOS.save over. So what I'm going to do is I'm going to power it down. We cut the power. I'm going to remove, there we've removed the disk from the flash floppy. And so it can't boot off floppy. Let's power it up. Okay, that was very fast. So we're on volume 10 now. VQ. And if we do VQ on volume 0, since I've got the disk removed, does it tell me? Yeah, no disk on volume 0 as it should be. But volume 10 is set up. We've copied all this stuff to it. It seems usable. Ought to still be there. System. Alright, so in retrospect, I built it, I showed it to you guys, it worked. I still want to do a few more things, so the two expansion slots are not populated. I do like designing expansion cards, so I think I will populate those, and I will try to come up with a speech synthesizer board or something like that. The other thing is we can run CPM 8000 on this. And I did not demo that in this video, but maybe next week we'll come along and we'll load up CPM 8000. You can see that work. And then finally, I think I would like to mount it in a case of some sort. Maybe build a wooden case or something for it. I don't really want a big old huge generic looking ATX tower case or something. That wouldn't be very fun, but some kind of little purpose-built case for this. We'll see if we can make it look nice. So expect at some point a second video on it. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.